Let's work an example using the coefficient of friction. Let's say that I pull a wagon in which Greg Cribb's mom is sitting, and pull it across the ground. And let's say that the wagon has a mass of 10 kilograms, and Greg Cribb's mom, GCM, we'll start calling her for short. Greg Cribb's mom has a mass of 150 kilograms.
Jesus.
So, furthermore, let's say that I pull her with a force of 400 newtons. Now, there's a lot of ways we can construct this problem, but I'll start with the simplest. The simplest way to construct this problem, which people always miss on the test. Ready to miss this on the test? I'm now going to say this. If she goes 4 meters per second, a constant 4 meters per second, what is the coefficient of kinetic friction? That is the question that we're going to ask. If you're going constant 4 meters per second, what is the coefficient of kinetic friction? The way that we will do this, we'll start with a force diagram. We always, I don't know if you caught on to this yet, but we always start these problems with a force diagram. And I've already drawn the first force of me pushing forward at 400 newtons. What are other forces going on here? Graviton. Which way is graviton pushing her?
Down.
Down, down, down towards the...
Wow.
One way, I haven't done this yet, but I like to talk about it pulling you straight to the center of the earth, right? Which some people call that hell. That's where hell is, they say. Right down. So we have, some people call this the hell force, but pull you right to hell. And that means, what other forces are going on here?
Normal.
The normal force, which is pushing you up, away from hell, right? That's why some people like to call that the Jesus force. But you got the weight down, the normal up. I happen to draw them of different sizes. Should I have? What? Should I have different? Should they be the same size or different size?
Same.
It should be the same. I made a boo-boo. So, I don't want to mess with it now. So they should be the same size. Is that it? Hmm? What? Friction. Which way is friction pushing Greg Cribb's mom?
Right.
That way. Left.
To the left. I like you scared of. Now, I drew it of an arbitrary size. It might be bigger, it might be smaller, whatever. What? Those are all the forces. We have the normal, the weight, the... I didn't label this. What would we call this? Well, anything that is kind of pushing you forward, we tend to call that a thrust force. Usually, like if an engine is sending a rocket up or a car across something, we'll call that the thrust force.
Thank you.
And we'll call that the friction force. And what do we know now? How are we going to answer this question? It's okay if you miss it now, but you're not going to miss it on the test, are you? You are? Oh, Lord.
There's no acceleration.
There's no acceleration. Therefore.
There's zero forces.
What?
Zero forces.
You gotta be careful when you say there's zero forces. There's lots of forces. We just labeled them.
There's no norm.
No net
friction.
force.
There's
Or
no
net
what?
force, my bad.
Net force.
There's no net force, isn't there? Now we already knew that these two arrows canceled each other. What do we know now?
With those two.
We know also that these two forces cancel each other. How do we know that? Because there's no net force. How do we know that? Because there's no acceleration. If these cancel each other, what's the friction force?
400 newtons.
400 newtons. Oh my god. If the friction force is 400 newtons, can't I find the coefficient of friction if I know the normal? Now what am I going to use for the normal? What's the normal force here?
9.8.
What?
9.8.
9.8 is an acceleration. What's the normal force?
150 kilograms.
150 kilograms?
150
Can't be it.
times
You had to times it.
Oh,
yeah, I was
yeah.
getting to that.
So the question is, what is the normal force on what? Is it really the wagon we're interested in, or is it Greg Cribb's mom, or is it both?
Both.
Both. The ground's got to push up to hold her and the wagon up, right? So the normal force is going to be the force needed to hold Greg Cribb's mom and the wagon up, which is,
168.
how'd you get that?
160 times 9.8.
So we know the normal is equal to the weight, right? And we know the weight is the two masses together, 150 plus 10 times 9.8, which is, what did you say that was?
1,570
Unit?
newtons.
So we have 400 is the friction force. That equals mu times 1,570 newtons. So mu is 400 over 1,570, which is? What? 25. Unit? No unit.
60 times.
There we go. We just found the kinetic friction coefficient on this problem. Shut off the camera.